Hey everyone, welcome to Describely. My name is Kesari Nandan and today we are going to solve the LeetCode problem median of two sorted array. This is a hard problem on LeetCode. So let's read the description of the problem. So it says given two sorted array num1 and num2 of size m and n respectively, return the median of the two sorted arrays. Okay, so the overall time complexity should be O log m plus n. Okay, so the easier solution would be to merge these two array and then find the middle value, and that will be the median of the array, but that will take the time complexity of log O m plus n. But here the problem statement is saying that we cannot use that, we need to use lesser time complexity, that is O log m plus n. Okay, so that means we cannot use the merge way. Here two examples are given. Example 1, the input num1 contains two value 1 and 3, and num2 contains list with only one value, that is 2. And if we see how the middle value, so if we combine these two, right, it will be 1 2 3 and the middle value is 2, that is the median one. So you can see the answer 2. Okay, here it was odd, so that's why we were able to find the middle value. But in the example 2 you can see we have two element in the num1 and two element in the num2, so the total combination will be 1 2 3 4, and if we try to find out the middle value, right, that will come somewhere here. Okay, so to get this middle value, what we can do, we can just add this 2 and 3 and then divide by 2, so that will be 2.5, and that's your answer here. Okay, so we need to find the left side and the right side of this merged array somehow without merging it. Okay, so let's first understand the problem and try to come up with a solution, and then we'll do the dry run, and after that we will write the code here and we'll test our solution. Okay, so here I have taken two array, and this is not coming from the example given in the question. This is I have taken more values in the array. So array A contains 4 values and array B contains 6 values, and if I merge them, you can see this is the merged array, and here I have total 10 values. I have taken the even because when we are calculating the even, right, we need to actually take two values and then add them, and then we need to divide by 2 so that we can get the median. In case of odd, it's pretty simple. I will cover that case also. So let's actually visually find out the median of this merged array. So if we see here, you can see these are the 5 element on this side, and here also these are the 5 element. So the median will come here somewhere, right? And to calculate the median, what we need to do, we discussed this in the problem description, we need to add these two number, right? So we can say median is 5 plus 6 divided by 2, and that will come out to be 5.5. so this is our median. To calculate this, actually I want you to understand one thing. Let me actually draw this line. So let's say I have drawn this line here. Okay, and if you notice this thing, we have 5 element on the right side and 5 element on the left side, right? And these 5 elements are sorted and these 5 elements are also sorted. Okay, and one more thing, if you notice that all the element on the left side are smaller than the element on the right side. Okay, so let me actually write this left side element and the right side element in the order, but I will use array A and array B. So let's say this is the element that I am getting from array A. So I'm getting, I'm having 1 3 5 from array A. So I can write 1 3 5 here, and what is going on the right side from array A, that is 7. So on the right side I have 7, and if I look the same thing in the array B, then I have 2 and 4 from the array B, and I have 6 11 13 and 14 on the right side from array B. Okay, so since we don't need to merge this, we cannot merge this because that will increase the time complexity. So we need to find out a solution to identify these elements, left side and the right side, without merging them, right? And if you look into this, right, so you can see all the element on the left side are smaller than the element on the right side. You can see this 4 is smaller than this 7, and also this 4 is smaller than this 6. And if I talk about this 5, this is also smaller than this 7, and this is smaller than the 6. right? So we need to make sure the element on the right side are greater and smaller, I mean larger, and the element on the left side are smaller, right? Let's check if this condition satisfies. If we take three element from the array A on the left side, and we put two element on the right side, and we take three element from array B and put other element on the right side, right? So for that, I'm let me just scroll it little bit. So what we are going to do, we are just going to take two element, right? So if I take two element from the array A, then I will have 1 3 here, and 5 7 will go on the right side. And how many element we are requiring on the left side? We need 5 element on the left side and 5 element on the right side. So we have got 2 here, right? We need 3 more elements, so that we need from array B. So we can get 2 4 6, and this will be 11 13 and 14. Are these array smaller than all the element on the right side? No. So you can check 3 is less than 11 and 3 is less than 5. That is fine. But here you can see 6 is not less than 5. So this is not our answer. This means if we combine them, right, then we will have 1 3 1 2 3 4 6 5 7. So you can see this is not sorted array. So this is not our answer. So we can use this logic and we can solve our problem. So what we need to actually do, we need to make sure the element on the left side are smaller than the element on the right side. And if you see here, let me take another color. So if you see here, this 5 4 7 and 6, these are the element that we require to check if this is a valid combination or this is invalid combination of array and B, array A and array B. So let's call this L1, and this is L2, this is R2, and this is R1. So I will also show you, if I take one element, if I start from by taking one element on the left side, right? So I will have one here, and I will have 3 5 7, and you can, since we have taken one, we need 4 more, so we can say 2 4 6 11, and here 13 and 14. This will, you can see these elements are not smaller than this one, because 11 is greater than 3, so this is not also a valid answer. Okay, so we need to make sure that our L1 is smaller than R2 and L2 is smaller than R1, because L1 will be smaller than R1 since we are taking this from array 1, right? So this is sorted array, so this will be I mean the L1 will be smaller than R1 obviously, and L2 will be smaller than R2. We just need to check this L1 is smaller than R2 and L2 is smaller than R1. Okay, so let me okay, so let's write an algorithm using the logic that we have discussed till now to find out the solution for this problem. Okay, so let me divide this page. Okay, and if I write the array A, right, here you can see we have 1 3 5 7, 1 3 5 and 7, and in array B we have uh, 2 4 6 11 13 and 14. So this is the input right now we have, and what we need, if we discuss here, we need L1 L2 R1 and R2. These are the required value to actually calculate the to find out the solution, right? And before that, we also need to make sure that we have 5 element on the left side and the 5 element on the right side. So let's try to write a logic to find this left and right. And for that, we need, let's say we have M, and M is basically the length of A, and we have N is basically the length of B. And if we try to calculate the total length, right, so this will be M plus N. Okay, and when you actually, let's say you have this the total number of element, you have 5 plus 5 10, right? And you can, if you want to get the left the number of element on the left side and the number of element on the right side, right, so you need to divide total by 2. Okay, here we have 10, but let's say if we have 1 2 3 4 5, and if you want to get the left, so your left could be this one, or it could be this one. It's depend upon you how you want to get the left. So in my case, what I want to do, I want to take 3 element on the left side and 2 element on the right side. So for that, what I need to do, I need to do 5 plus 1 divided by 2, so that it's a 6, and 6 divided by 2, I will do the floor division. This will give me 3. So I will get the 3 element on the left side. And whenever I need to get the median, what I will do, I will take the max from the left side, L1 and L2. This is L1 and L2, and this will give me the median in case of odd. So that's why I'm just going to do the total plus 1 here to get the left side element. Okay, I hope that makes sense. So if I try to get the left side element total, right, so this will be total plus 1, and this will be divided by 2, floor division, and this will give me the element on the left side. Now I have the element on the left side. Okay, so here I want to use the binary search to find out the median, and I will take the smallest array here, that is the A. And how the binary search works, you take the length of the array, so I will take the 0, and the total is 4, and then you divide at them and you divide by 2, right? So this will be 4 plus 0 divided by 2, and this will give me the 2. So 0 1 2, so this here I will reach here. Then I will check if this value is less than or greater than the value that I'm looking. So if this value is greater than the value that I'm looking, right, then I will move this side, and if the value is greater than what I'm looking, I will move on this right side. So I'm just going to use this logic to solve this problem, and for that I need this mid, right? I need to calculate the mid value first. So let me calculate the mid. So this will be, actually I will be running a loop, and in the loop, to calculate the mid, let's say I have low here, and this is 0, and I have high, and this high is the length of the A, and this is 4, right? And let me also write the code here. While low is less than or equal to high. Okay, now I need to calculate the mid. So let's say mid, and this mid will be low plus high divided by 2. If I write mid here, in this case, so this is mid 1, so this will be 0 plus 4 divided by 2, and this will give me 2, right? And I have taken, let's say, this 2 element from the array A, right? I will also need the mid 2 from the array B. That will tell me how many element I need from array B. And how can I get that? So I can get that by I have the total element on the left side, right? And if I write the left here, then left is basically total plus 1 divided by 2. So this is 10 plus 1, 11 divided by 2, and this will be 5. So I have left on the left side total 5, and I have this n mid 1 that I have taken from the array A. So if I need to take some element from the array B, that will be, let's say, mid 2. This is mid 2, and this will be total element on the left side, that is let's say left, and minus the element that I have taken, mid 1. So this will be the mid 2. So if I write here mid 2, this will be left is 5, value I have taken 2, so I need 3 element from the array 2. So 2 element from array 1 and 3 element from array 2. This will be my left array. Okay, now I have the mid 1 and mid 2. Now I need to find out this L1, L2, R1 and R2, so that I can compare if this the element that I have taken on the left side are valid, right? So for that, what I can do, let's write the R1, and what will be the value of R1? So if I take the R1, then R1 will be my mid 1. You can see this R1 is coming from the array A, and we have taken mid 1 for array A. So I can say A, and I can say mid 1. This will be my R1. But there is a case, and the case is this. If I take one example here, right, let's say in this box, and my A is uh, let's say my A is 1, okay, and my B is, let's say, 2, 3, 4, 5, 6. And if I combine them, this will be 1, 2, 3, 4, 5, and 6. And if I try to calculate the mid, right, so this will be 6, and divided by 2, this will be 3. So in this case, I need the 3 element on the left side. So this is 3 and 3. If I divide this, so I'll take 1 here, and I cannot take any more. So I need to take 2, 3, uh, 2, 3 from array B. Let me write here. So 2, 3, and 4, 5, 6 will be here. So now I have this value as L1, this value as L2, this is R2, and what is the value of R1? So value of R1 is infinity, because we need to compare, so we need to have a numerical value there, right? And when we need the infinity, when this will happen, when in that case, when our mid is basically greater than the length of A. So if our mid is greater than the length of A, in that case we need to assign the R1 as infinity. So we need to make sure that whenever we are calculating the trying to get the value from the array A, right, this is inbound, this is not going outbound. So we can check if this mid one that we have is basically less than the length of A, and length of A is M. In that case we will need this one, and in case of else we will take this inf. So we can say float, I am writing in Python, so inf. So this will give us the infinity, right? Same goes for R2. This can happen on the R2 also. Let's say this is A and this is B. In that case, this will happen again in case of R2. So there also we can say B, and here we need the mid 2, and we can say if mid 2 is less than N, else float inf. Okay. Now if I talk about L1, right? L1. So let me actually delete this. I mean the remove these values, and I just want to change a little bit this array, and this is 11 now, right? So in that case, the merge array will be 2, 3, 4, 5, 6, and 11, and mid will be 3. So this will be 3 and this will be 3, right? And if I try to write the A, right, I cannot take anything from the array A, because the value that array A is having is greater. So I don't need to put anything on the left side. This will be empty, and here I will have 11, and I need two more value here, so that is 5 and 6, and I will take 2, 3, and 4. So in that case, here I cannot leave it blank. I need to put this to minus infinity, so that I can compare this. Okay, so same goes here. So if I'm calculating the L1, so what will be the L1? So let's say here we have this is R1, right? This is R1, so L1 will be R1 minus 1, because if you see the index, so 0, 1, 2, 3, 4, this is the 4 index, and this is the 5. So 5 minus 1, 4. So this is 4th index. So in that case, we can say A, and we can say mid 1 minus 1, and here we can say if mid 1 minus 1 is greater than or equal to 0. So this is, if this is within the array, then we will take this value, otherwise we will set this to minus infinity. So here this will be float minus inf. And in case of L2, same thing will happen if we uh, exchange the array. If let's say assign this array B to array A and array A to array B, then here we will have minus infinity. So here we can say mid 2 minus 1, and that will again go to if mid 2 minus 1 is greater than or equal to 0, else we have float minus inf. All right, so we have our R1, R2, L1, and L2. Now we need to apply the condition here, and the condition that we discussed is if L2 is less than R1 and L1 is less than R2. That means we have found our answer, right? So we can check if L2 is less than or equal to R1 and L1 is less than or equal to R2. If this condition satisfies, that means we have found our answer. Now we need to find if the total combined length is odd or even. Okay, so for that we can say we have total here calculated total, so we can check based on that. So we can say if total modulus 2, if this is not 0, that means this is odd, so we can return. And what we can return, we can take the max of L1 and L2, because if you remember I have discussed this here, max of L1 and L2. So here we can take max of L1 and L2. This will be our answer if this is odd. In case of this is not odd, then what we do, we take the uh, middle two middle values and add them and then divide by 2. So in that case we can take max of L1 and L2 and plus min of R1 and R2, and then this will be divided by 2. You already understand why we need L1 and L2. I will explain you why you need R1 and R2, right? If you go here, right, so you can see we have 4 and 5, and if we need 5, since in this array we need 5 and 6, right? So we need to take the max. That's why that's how we can get the 5. And here if I talk about the 6 and 7, this is 7, so we need to take the min. So that's why on the right side we take the min and on the left side we take the max. So here we are taking the max and the min and then we are dividing by 2. This is our answer. We will not do the float division because if you remember in the question, right, this is expecting a float, so we will not do the float division. But if this condition doesn't satisfy, then what will happen? We need to reset our low and high based on the mid that we have got, right? So here we can check else if. So there may be two conditions. Maybe this L2 is greater than R1 or L1 is greater than R2. So we need to check both the condition. So we can check if L2 is greater than R1. If L2 is greater than R1, so what is L2? L2 is basically we don't need to check the L2. We can do the L2 in else part, since we are running the binary search on the A, right? So let's check the L1. So we can say else if, and we can check if sorry, not L2. So we can check if L1 is greater than R2. If L1 is greater than, not greater than or equal to R2, in that case we need to basically move our high. So what we are checking, we are saying that L1 is greater than R2. That means if I come here, this L1 is greater than R2. That means we need to go on the left side, because we have this L1 is greater than R2. So we need to come here. So what we will do, this is the mid. So we will set the high to this one, this minus this. So our high will be, in this case, high will be mid, that we have got mid 1, and this will be mid 1 minus 1. In case of if we found that the R2 value is not at the center what we wanted, then we need to move the low. So we can say low equal to mid 1 plus 1. So this is our final solution, and eventually that will come into this one, and we will get our answer. So let's code this into LeetCode and try to run the test cases there. Okay, so I am on LeetCode again, and let's write what we have discussed. So if I calculate the length of num1, right, so this will be m, and this will be length of nums1, and n is the length of the second array, that is nums2. Okay, now since I'm just going to run on the smallest array, right, I need to make sure that num1 is the smallest one. So what I can do, I can check if m is greater than n. In that case m is not a smaller one, so I can just return this, and I can say self dot this array, and now I can pass the nums2 first and the nums1 first, so this will be swapped. Okay, and now we are sure that the this nums1 is the smallest one. Okay, so what we did there, we calculated the total number of element that we have. So let's calculate that. So total will be m plus n, and after that we calculated the number of element we need on the left side. So that is left, and that was total plus 1, and this should go inside parenthesis, and we will do the floor division. So we have now the number of element we require on the left side. So this will be total number of element on the left side, and we need 2 pointers, that is low 0, and we also need the high, that will be the total number of element on the smallest array, that is m. Okay, now we need to run our loop while, and while we see that low is less than or equal to high. Okay, now we will calculate the midpoint. So in the first array, so mid 1 will be, and this will be low plus high, and we will divide that by 2 so that we can take some element from the left array, and the remaining element mid 2, and this will be the total element that we require on the left side, that is left minus element that we have taken mid 2. So this is the basically the pointer, mid pointer in the first array and the mid pointer in the second array. All right, now we need the r1, r2 and l1, l2. So r1 will be, what we did there, we took the element at the midpoint, and to get that we can say nums1 and then the mid one, and we had a condition, if you remember, we need to make sure that this index is inbound, it's not going outbound. So in that case we can check if the length of, or we can directly check, since we have length already, so we can make sure if this mid one, the index is less than the length that we have for this array, that is m. And if this is not the case, in that case we can set this to infinity. So we can set this to inf. Same will go for the r2. So let me copy and paste this. So this will be r2, and here we will have nums2 and mid2, and here we will have mid2, and this will be n. In case of l1, we need that, let me copy this, nums1, and now we need to take the element before this r1, right? So we will decrease the index by 1, and now we need to make sure, since we are taking the element before, we need to make sure that it's not less than 0, right? So we can check if mid 1 minus 1 is greater than or equal to 0, and if it's less than 0, then we will set this to minus infinity, and same will go for the r2. Here will be second array, and the second index, mid index, and here this one also, and this is fine. Now we have our 4 pointer that we require. Now we need to check the condition. So condition will be if L1 is less than or equal to R2. This is the first condition, and the second condition was if L2 is less than or equal to R1. If this condition is satisfied, then we need to check if the array that we have, I mean the combined array that we have, that is odd or even. So we can check if total, here we have total, you can see. So if total modulus 2 equals to 1, that means this is odd. So in that case we can return the max of L1 and L2 as I discussed, L1 and L2. In other case, if this is not odd, in that case we need to add those 2 mid values, right? So we can take max of L1, L2, and this will be plus min of R1 and R2, and then we need to divide this by 2. We will not do the float division here because the expected value, if you remember, this is float. So this is fine, and if we don't find this answer at the mid that we have set here, that means we need to move our low or high. So we can check if our L1, this one L1 is greater than R2. So if it's greater than R2, that means our answer lies in the first half, I mean in the lowest part, right? So in that case we can move our high, and we can say high will be our midpoint that we had -1. So now this is our high, and again we will calculate the mid again. So I will take now the entire left that we have taken divided into two parts. So first half and the second half, and now since the mid was greater than what we were searching, so we need to find the that means basically we have our answer in the first half. So we will take the we will move our high to the mid -1, and we will try to find the mid into that one, and that's how the binary search works. And in case of else, we will calculate our low. So low will be mid 1, and this will be +1. Eventually everything will fall into this condition, so we don't need to worry about. So we can just try to run this one, and let's see if all the test cases are passing. It says L1 is not defined, did you mean R1? So here we, okay, this is actually L1 and this is L2, and this is L1. Okay, so let me try again. All the test cases are passing. If I submit this, alright, so you can see all the test case has run, and we have successfully solved this hard problem on the LeetCode. So thank you so much for watching this video, and if you are new to this channel, please subscribe to the channel, and click the like button.